Hey, Seven.
Yes, friends, indeed, it is the circle of life, the area of circles, and building upon what we've already done with the circumference of a circle. Hopefully, this will not be so much of a stretch. So, in your books on page 72 and 73, you'll be asked to draw in some notes and follow along and figure this out together with me. So, if you're not there, go ahead and pause this video and get to your book. All right. We're going to go ahead and read through this example. It says, Professor Smart is teaching her students how the formula for the area of a circle was derived, or how they found it. She cuts a circle into equal pieces and rearranges them below. They almost look like pizza slices next to each other. Now, if you'll notice, this length right here is the same as the length of one of these pizza slices, and that represents, if you remember yesterday you talked about the diameter, so this represents the radius, right? So it's halfway across. And in fact, if we look down at our questions down below, it says, what general two-dimensional figure do you see when the pieces are rearranged? What is the formula for the area of that shape? Now, if you'll notice also, and I should specify this, right over here represents about half that circle, right? So that's about halfway around. So that represents about 1/2 of the circumference of a circle. Okay. Now, if we think about it, if we look at the general two-dimensional figure, so if we looked at this figure here and we kind of rounded it or softened up the edges and made a shape out of it, it resembles a parallelogram, right? And whenever we try to find the area of a parallelogram, we know that the area is equal to the base times the height. Okay, so based on the diagram above, how is the circumference of the circle related to the length of the parallelogram? Well, again, I kind of brought that up before, but the length of the base, and I'm going to kind of shorten the notes here, length of the base is equal to half of the circumference. I'm going to kind of abbreviate everything. Okay, so length of the base is 1/2 right here. I'll kind of draw over again. That's about half the circumference. So that's basically the base, right? So up here, for our purposes today, we could show or find the area in 3 different ways. We could say, well, we could find, just like we mentioned just a second ago, 1/2 the circumference times the radius. We could do 1/2 times 2 times pi times radius times the radius, which to me seems a little bit overwhelming. Or we could just simplify it all down to pi r squared. And that's what we're going to do. We're going to be using that formula, plugging in the information that we have in order to find the surface area of a circle. Okay? Moving right along, area is the surface measurement of a two-dimensional figure. It is the square units. Kind of have to scrunch here, that cover a circle. Use the formula again. Area is equal to pi times the radius squared, where r is equal to r, radius, times the radius. So down below here, we're going to go ahead. Here's our radius here. We already have it. It tells us it's 3 inches. Our formula is equal to pi times the radius squared. So we don't have the area. We have pi remember what we have represent pi, and that's 3.14. And the radius is again 3, so 3 squared, which is 9. Now, it tells us to write it in terms of pi. That just means leave pi as a symbol and not turn it into 3.14. So we could say, well, pi times 9, or if we write it the correct way, it would just be 9 pi. So 3 squared is 9, right? Times, leave 3.14 as a symbol. It's just kind of flipped around there. And so if we found that, it would be, the area would be, if we multiply that all out, 28.26 inches squared. All right? Okie doke. Going on to the next one, circle 2. Again, we're going to take it. Maybe it will be seared into your brain that area is equal to pi r squared. Again, we don't know the area yet, but we know it's 3.14 is our rounded pi number. And our radius, if the diameter is 10, we know to cut it in half, and that would be 5 squared, right? So half of it is 5. In terms of pi, well, 5 squared is 25, right? So we would write 25 pi is equal to the area. And our total area, if we found it, would be 78.5 centimeters squared. All right, the last one in this row. Lucky for us, we have the radius is 6 meters. Formula, remember, pi r squared. Plug in our values. We don't know the area. We know we could plug in 3.14, and our radius squared is 6 squared, right? In terms of pi, we're just going to square that, and it's going to be 36 pi. And that's our area. And if we actually multiplied it out, we would have area is equal to 78.5 centimeters squared. So that's a kind of a quick rundown how to apply the formula or plug in our numbers and our values that we know and find that. Now the next section, it says to use your understanding of the area of circles to answer the following questions. A circle has an area of 78.5 square inches. So now we know the area is this. So remember, area is equal to pi r squared. So now we know that that's our area. That's going to be plugged in for area. Is equal to, well, we know that pi is 3.14, but we don't know the radius squared. That's what we're trying to find. So we've got to get that by itself here. So we're going to go ahead and divide by 3.14. Divide by 3.14. And we're left with r squared on one side. And 78.5 divided by 3.14 is 25. Let's go ahead and do the next problem. On number 2, it says a circular sprinkler system is installed and waters an area of 28.26 yards squared. What is the radius of the circle? So here again, we have the total area of 28.26 yards squared. We're going to go ahead and plug that into our formula when we have area equals pi times radius squared. So our area this time is 28.26. Whoops. Yeah, not doing very good here. 28.26 equals 3.14 radius squared. So then we're going to go ahead and divide by 3.14. Divide by 3.14. And we should get, we'll kind of bring our answer over here. Our radius squared is equal to 9. We can go ahead and, to isolate the variable, take the square root of the other side, which is 3. So our radius equals 3. All right, number 3. Jada says that if you are given the circumference of a circle, you have enough information to find the area of the circle. Is Jada correct? Why or why not? If you think about it, if you have the circumference, you know that you could always divide by pi to find the diameter. And if you know the diameter, you can find your radius. So Jada is correct. So we're just going to write Jada is right. You can work backward to find the radius. So if you have your circumference, you could divide by pi. That will give you your diameter. And you could cut that in half. Whoops. All right, going down to the bottom, it says determine whether area or circumference is described by each statement below. The amount of fencing around a circular garden. Well, the key word there, and I'm just going to kind of highlight, is around. So if it's around, we're talking about circumference. Letter B, the amount of frosting needed to cover a cookie. The key word there is to cover, so we would be working with area. Letter C, the amount of crust needed to cover a pie. Keyword again dealing with the area. And the last one, the distance traveled in one lap around, would be circumference. And I actually had a student that mentioned that circumference is essentially the perimeter of a circle. So you could think of it that way. So if when you're talking about around something, you're referring to the perimeter, which deals with the circumference. All right, so we're going to use this image right here to help us as we go through these next couple of problems. It says 2 different trees are being planted in an outdoor garden. Each tree requires a specific amount of space for the roots to grow. How much more space will tree 2 required? So basically, we need to know, well, let's focus on what we do know. We know that for tree 1, I'll just put T1, that the radius is 8 feet. Tree 2, kind of draw a little arrow, the radius is 9 feet. Okay. What we need to know how many more square feet will tree 2 require? How many more square feet, and I'm abbreviating here, will tree 2 require? All right, so we're going to go ahead and plan and work. We're going to find the area of tree 1, and remember, area is equal to pi r squared, so we're just going to plug in our values, right? So 3.14 times the radius squared, which is 8 squared. And if we were to multiply that out, 3.14 times 8 squared, which is 64, we would get an area of 200.96. All right. So, and if we did the same thing with tree 2, we would still use the same formula. So our area is going to be 3.14 times, and it's 9 squared instead of 8 squared this time. So if we did multiply that out again, we would get that the area is equal to 254.34 feet squared. So if we were to find the difference, going back to what I need to know, how many more square feet will tree 2 require? So how much more is this than this? And I could just subtract it, 200.96 from 254.34. So tree 2, and you can abbreviate it here, will cover 50 3.38 feet squared, more than tree 1. Okay. All right, your homework today. You are going to be asked to look at the work of Ben and Luna. They were asked to find the area of a circle with a diameter of 9 centimeters. Use their work to answer questions 1 and 2. So what I would do here is I would go through and actually solve the problem and look at each of these students, how Ben solves it and how Luna solves it. Which one had an error in their thinking and where exactly was that error? So that is your part of your assignment. So you will be responsible for finishing that assignment on, I think, let me see, what page is it? Page 73. So good luck. May the force be with you.